Hello, today we're going to talk about area of a triangle. So we're going to start some new material. First you might think, well, this is going to be super easy because area is 1/2 base times height. The problem is for height, you need to know that this is perpendicular, and we don't always know that, and sometimes it's just a pain in the butt to find out. So we are going to do a new formula that you don't need the height to be perpendicular. So let's start off with that same picture here, and let's say we have the formula area equals 1/2 base times height, and I'm going to pull off this triangle here. There we go. Let me label it. Let's see, we got C, H, and that's pretty much, oh, and we know this side is A. One notation note for triangles is that the side is the same letter as the angle it is across from. So capital A angle, lowercase a side is across from that. So we have this pretty triangle here. We know, because this is a right angle from SOHCAHTOA, that sine of C equals H over A in this picture. So now if I rearrange this, I can say A sine C equals H. So I'm going to substitute in here what I have for H, and I get my new formula, B A sine C, and because I like things alphabetical, I'm just going to do some switching and change it to AB sine C. Alright, so this is our formula now for area. We don't need to know H, perpendicular height, we just need to know two sides and the angle in between. So this angle here is always the included angle. And by that I mean the angle between the two sides that you're plugging in for A and B. Alright, so let's do an example. First one's pretty easy. We got two sides of a triangle, 10 and 8. The angle in between the sides is 48 degrees. I suggest, even though this is kind of worded easily, is to always draw a picture. Doesn't have to be to scale, as mine is not. So 48. So area equals 1/2 the two sides sine of the angle in between them. Then we're just going to type that into our calculator. Make sure that you are in degrees. So here we are. Make sure you're not in radians at all, because all of this is going to be done in degrees. So then I would just do 1/2 A times B times sine of the angle in between, and we get our answer. So if we go back, this is just area equals 29.7. We'll just round to the tenths is fine. And what are our units? Inches squared. So pretty easy, just a new formula. Then we have the next type of problem where it gets a little more complicated, but not too bad. We have an area, we're given two sides, and we want to find all possible measures, which should trigger in your mind. That means there's probably more than one. So let me write out, let's draw the picture first. And usually I just call this A, B, C. It doesn't matter which order you write them, just as long as the side that matches it is across from the angle. So like side B is across from angle B. So A is 6, C is 6, and we want B. So at least we're finding the angle in between the two sides we're given. So we are going to do the area equals 1/2 the two sides, and we want the sine of the angle in between them is what we're solving for. So we get 12 equals 1/2 36 sine B. Do a little algebra. All right, so now we have to go back to our calculator and do inverse sine. So second sine of 12 over 18 is 41.8 degrees. However, we want all possible angles, and this is where a little bit of our unit circle comes into play. We just have to know the quadrants. So since sine is your y value, it's positive in both the first and second quadrant, and we don't know which angle this is. Because my drawing, I just drew an acute triangle. I don't know if it's actually an acute triangle. So I have to find this other angle by doing 180 minus this. So 180 minus 41.8 degrees, and that is 138.2 degrees. Therefore, B could be 41.8 or 138.2. And that is your answer. Not too bad so far. Don't worry, not going to get much harder. All right, so now we have parallelogram. Again, as I said, if you don't know where to start, always draw a picture. So draw a parallelogram, best of my ability. All right, so we got 12.5. We know this is 12.52. We know this is 8, and this is 8 as well. All right, so we know the included angle is 40 degrees from the question. So I'm going to put that in the correct acute angle location. And we want the area. Now, since this is a parallelogram, if I draw a diagonal here, we have two congruent triangles because we have side, angle, side. So we know these are the same triangles. Therefore, if I find the area of one, I can just multiply it by 2 and get the whole area of the parallelogram. So the area equals 2 times 1/2 8 times 12.5 times sine of 40 degrees. So the area equals 2 times, if you type that in your calculator, you should get 16.1. And so your total would be 32.2 centimeters squared. So the area of 1/2 of the parallelogram is 16.1, and then the total is just twice that. Right. Couple more problems, and then I'll give you some practice to do. The next one looks scary, but it's actually very easy. So we have an inscribed heptagon. So that's 7-sided inside a circle. It does have to be a regular heptagon for this to work. So we got to assume that. And that all the vertices then touch the circumference of the circle. And the radius of the circle is 5. So if I were to draw this, that's 5. That's 5, and I could keep going all the way around. There we go. So all the radii are 5. And so these are all going to be the same triangle. And the angle in between the two sides, since it's a circle all the way around, would be 360 times the number of triangles, which is the same as the number of sides. And that comes out to approximately 51.4 degrees. So now I have 7 of those, so I can do our area formula. I have 7 triangles. 1/2 5 times 5 times the sine of 51.4 degrees. So I type that in and I get 7 times 9.77. So the area of the whole heptagon is 68.4 inches squared. And you can do this with any shape as long as it's regular and inscribed into the circle. So it could be an octagon, a nonagon, a hexagon, any shape, as long as it's a regular shape. All right, and this is the last example. It's a little more involved, so hopefully I don't run out of room. All right, so we have this quadrilateral. We don't know pretty much anything else about it. And the good thing is we have a 90 degrees. So right now we can only do problems with 90 degrees because we have to know a few more formulas to do something more in depth. All right, so we got this quadrilateral. And first thing I'm going to do is draw a diagonal, so I cut it into triangles. So you always want to draw that diagonal through the angle that's not the 90 degrees. We want to keep the 90 so we can use SOHCAHTOA on some parts of this. All right, I'm going to label some things now. I'm going to do A1 for the first area, and this will be A2. I'm going to call this angle X, this angle Y, and then the diagonal we'll call C, since in this right triangle it is the hypotenuse, so we can call it C. All right, so first thing, let's work on area 1. Area 1 is easy. It's a right triangle. We have the base and the height. We can still use the 1/2 AB sine C if we wanted to, because from your lovely unit circle, you know the sine of 90 is 1, so it kind of just goes away. And so we get 1/2 4 times 10, so that's 20. All right, so first area done, bam. Now the problem comes is in the second triangle, we have one side and that's it. So the 100 degrees is not evenly divided. We don't know how it is divided, so we got to figure that out. So I'm going to find X first. So I'll do the work on the left of the figure. So if I'm looking for X, I can use tan of X equals opposite, which would be 10, and adjacent, which would be 4. So I am going to type in my calculator inverse tan of 10 divided by 4. And I get 68.2, we'll call it. So X equals 68.2 degrees. And then to get Y, I just have to do 100 minus that. So that Y equals 31.8. All right, so let me put those numbers in here so we can see what we got. So this is 31.8, and this is 68.2. All right, so now in the second triangle, this one here, I have one side, one included angle. And I need that side C, and then I can do the area. So to do that, I'm going to go back to the first triangle, and then use SOHCAHTOA to find that. So now I can say cosine of 68.2 degrees would equal 4 over the hypotenuse. And you could have done sine of 68.2 degrees equals 10 over the hypotenuse. Both ways you should get the same answer. So I would get cosine of 68.2 in your calculator comes out to be, we'll just do 0.37. And then if you solve this out by cross multiplying, you get C equals 10.77. All right, so let's draw that into our diagram. All right, so now we have two sides, the 14 and the 10.77, and the angle in between them. So I can find area 2. 1/2 14 times 10.77 times sine of 31.8. All right, so area 2, when I typed it into my calculator, I got that value, 39.73. Now for the total area, drum roll, equals area 1 plus area 2, 20 plus 39.73, and our total area is 59.73. No units are given here, so I'll just do units squared. All right, I hope this helped you out. Your assignment here is to do pages 2 and 3 in the Chapter 9 2020 packet. It's under the new COVID-19 module. I hope you're all staying sane, and I will see you on Canvas. Bye.